Great to be here on a Friday afternoon. So because it's now like almost 4:30, I'm going to try and be a bit provocative to spice things up, okay? And before I begin, I've got to say four things to put my talk in context. The first is that I am a political scientist, and even more so, I'm a Canadian political scientist, which means that we do a lot of work theorizing and conceptualizing about the world. We don't just look at data, but we think about and ponder everything abstractly, and we ponder a lot. And we think by pondering, we might intervene in ways that changes the future data that we look at, okay? So we're curious about changing data, not taking preferences as fixed or feasibility as fixed, but actually intervening to change feasibility and preferences. So the group that looks at preferences and feasibility as fixed, we call them ahistorical. Okay? Whereas I do historical work. And a buddy told me recently, nobody wants to be known as being ahistorical, okay? Which is a good point, but still they are, because they take preferences as fixed, and we're not taking preferences as fixed in this talk. But I do want to make the point that because of that, kind of squishy kind of stuff, I want to give you a little story. When my son, my oldest son, when he was 5, he said, "Daddy," that's when he used to call me Daddy. I said, "Walter, what do you want to be when you grow up?" And he said, "Daddy, I want to be a scientist, but not like you," he said. He said, "I want to be a real scientist," right? Yeah, so our first two speakers are the real scientists, and they give me the problem definitions that I care about. They give us the actual things that I care about pondering, okay? And by the way, that son ended up doing a degree in physics, and his cousin, my nephew, is doing a degree right now in operations research and engineering at this really cool university called Cornell. Okay? And he's right there. Massey, can you put up your hand, please? Massey, put up your hand. That's Massey. He's my nephew. He came to this talk. Okay? So I'm very excited about this. My very own nephew at this talk. Okay? So finally, the last thing you have to know about this talk is that I've gone through a sort of crisis in my own sort of research the last 3 or 4 years. It pivoted. There was a critical moment when there was this president elected in the United States. And it got me thinking about, what am I doing? Am I actually reinforcing a lot of these problems in the name of doing market-based governance and working on sort of technological solutions and scientific approaches? I'm actually reinforcing kind of a private governance effort that minimizes the state, okay? And so since then, I've been doing what academics do when you have crises. You write articles. And I've just written a bunch of articles on this crisis. And when I give my talks, I use you as my therapy, okay? So today, you are my therapy as I talk to you about some of the things that I'm pondering through, okay? So I told you this already, but I'm motivated by the real scientists, okay, who give us the issues we care about. And of course, climate change is probably the most environmentally important crisis facing the world. Massive species extinctions is a pretty close second, okay, that we're causing as well. And the scientists tell us this, how terrible and acute it actually is. And, the Polson Institute itself talks about the scale of transformations is significant to address these kinds of problems, to get us to what we want to do, this goal of net zero in the case of the climate crisis. So the conundrum for me, though, this crisis that I'm having, is that in the last 25 years, we've had a proliferation of policy tools and commitments to address this crisis. Okay? RED+, that's to reduce emissions from deforestation, degradation, financing for forests. Right? Finance is the answer. Eco-labeling that I work on, reward firms for being great, right? Through certification systems. Public-private partnerships where there's win-win-win solutions to address problems. And of course, we have this 1.5 degree commitment at Paris. And the emphasis on all these efforts are on finance and market-driven mechanisms, business and environment coalitions, and yes, science and technological innovations. Regulations are deemed to be inappropriate now for the most part. And so there's a bit of a challenge here because there's a disconnect between 25 years of experiments on these things and the fact that things are getting acutely worse. And what are we doing? We're doubling down on the very interventions that have not worked for the last 25 years. Why is that? Okay? So I'm going to actually argue that there are 2 different projects behind those promoting science and technology is the answer. Okay? Now, this is to the answer, not giving us the problems. Science is gives us the problems. But science and technology may not give us the entire answer because there are two different projects. And one is, there's a coalition, and I think most of them are in this room, that are focused on understanding how technology can get us to the 1.5 degree target. That's one coalition. But there's another coalition, and it's an ideological coalition. And it says that it believes that technology and market tools will tell us whether we can address the climate crisis. And this is your senator, right, in the op-ed piece. Right? No, the senator that you talked about. No, not your senator. No. You'd never vote for that senator, right? But that's this weather, right? So weather, we're giving technology the weather question, not the how, right? And the problem is, it's difficult to discern the difference because they actually look very similar in their prescriptions, but their projects for the future, for future data, are really different actually. One group constrains our options to just technological market innovations, and one thinks about opening up technology with other options to create innovative baskets that could be effective. And it's that one that I'm curious about actually triggering and talking about in my talk. So what I want to argue then is that technology right now, the studies in technology tend to be focused more on sort of the great stories about technology that's emerging to reduce carbon capture and storage and so on, the positive cases. So they don't look at the entire range of the dependent variable. They look at one range, the positive range of the dependent variable, and they miss the other side of the dependent variable. The simultaneous technological innovations that are increasing carbon out into the atmosphere that aren't predicted, but they happen because technology doesn't go in one way. It goes in all directions, right? Bitcoin is one example, but there are many, right? So these countervailing forces, and if you just choose the one side, aren't we over-exaggerating the impacts of technology in addressing the 1.5 degree goal? So my second argument is we've got to find a way to think about fostering technology as part of a broader range of policy mixes that, if you think carefully, may uncover some pretty cool solutions that aren't captured by the ideological coalition, but are instead chaperoning the problem-focused coalition, that we can actually punctuate lower carbon effects. And I've been working a lot on this, so I can give you a couple examples, but not much given my time, but I will give you a sort of highlight where this all goes and how we might actually do this. And to do this, I think we must first begin by thinking about the key features of this, of the climate change problem, which we call, with my colleagues, a super wicked problem. Super wicked. It isn't just wicked, it's super wicked, okay? It's not just a play in London, it's actually a thing, okay, that has actually some important features that we think whatever you do has to be in line with these features, okay? And then I'm going to argue that to do this, we can't use our regular policy tools, cost-benefit analysis, multi-goal policy analysis, stakeholder engagement around compromise. They don't work for this kind of problem. Instead, I want to offer that path dependency analysis, where we project forward multiple steps. Historically, looking forward might offer a solution. Okay? So that's my overall argument. And of course, to make this point, I have to have a 2x2 table, because in political science, to get published, the norm is a 2x2 table. And so I have one for you, okay? And it's kind of a simple one. I asked two questions. I did these 5 papers in my crisis, and I realized there were 2 questions that kind of you could coalesce almost all problem framing around. The first one was, in terms of problem conceptions, does utility dominate the problem conception in some way? Utility, this idea from our economist colleagues that human self-interest and motivations are what's at the heart of human preferences and behavior and feasibility, and so how do we enhance utility, okay? This moral philosophy of utility as embodied in the discipline of economics. And then the second question was, is this conception focused on a particular class of problems, or is it meant to apply to all problems in the world, regardless of the actual attributes of the problem itself? And from that, we get four types. So the win-win type 1 is the Elinor Ostrom tragedy of the commons. It's a utility problem where people are over-harvesting resources that if they keep on doing it, there'll be no more resources left. And so the challenge there is to develop collectively optimal institutions that allow you to harvest only at the same rate as the growth rate. okay? And so you get a sustained yield. And it's a utility-enhancing approach that Eleanor Ostrom won the Nobel Prize in economics for thinking of a new way of doing this, okay? But it's based on the features of a particular class of problems. She said in her first chapter of her book, this applies just to tragedies of the commons, not to everything, okay? Type 2 takes that notion but applies it everywhere, to every problem, in the form of what we call type 2 win-lose optimization, in which cost-benefit analysis or social welfare analysis tells you whether or not you can solve any problem by interrogating the solution method. And if that solution enhances overall utility, social welfare, you can solve the problem. But if it reduces it, you can't. So you never know what problems you can actually solve. It just depends on whatever this equation lets you do. This is an analytical scientific equation based on also utility, but it applies everywhere, regardless of the features of the problem itself. And then type 3 is also based on an approach that is irrespective of the problem itself, but it doesn't just use utility. Utility shares the stage with other values, such as environmental values for the sake of the environment, social concerns, culture, and so on. And usually this approach we teach in policy schools is about dispute resolution, stakeholder engagement, or multi-goal policy analysis, comparing, contrasting, and compromising, right? And there's a really cool case in Newfoundland where the science was very clear that the fish were going to actually become depleted if the fishers didn't reduce their harvesting by quite a bit. And the science was very clear. You got to stop harvesting so many fish. And so they invoked a stakeholder process, type 3 process. And they involved workers and municipalities and government, and they got a great compromise solution. Now, it wasn't in line with the science, but it was a great, legitimate, trustworthy, enhancing process that had a higher yield rate because it wasn't just the science that mattered. And you know the story. The fisheries collapsed. Okay? So type 3 solutions don't always work for what we think is really important is type 4, which we call win-lose prioritization. And this is when either the science or the norms tell you that to solve the problem, you cannot compromise it with others. Okay? And so environmental tragedies, species extinctions, and climate change, the science tells us if you trade it off with other problems, you can't solve it. Species is an easy one because if a species is extinct, the science tells us, hey, let's say in the case of the spotted owl, have more old-growth forests. If you don't have those old-growth forests, the species becomes extinct. So you either do what you have to do based on the science, or you lose it. So you must give it priority, and you can't compromise it away like happened in Newfoundland. Okay? So I'm curious then about what kind of tools do we use to address type 4 problems, of which climate change is the most important one. Okay, so working backwards from the nature of the problem itself, just the way Ostrom did on her problem conceptions for tragedies of the commons that were utility ones, what are the key features of type 4 super wicked problems with respect to climate change? And so just, long story short, we adapted Whittle and Weber's famous article on wicked problems to think about 4 additional features of super wicked problems. And what are they? First, time is running out. At some point, it's just too late. Okay? A lot of policies, like, for example, access to abortion rights, you can go back and forth in the policy process forever and keep on changing it. But with these problems, at some point, it's too late to solve the problem. That's the first feature. Secondly, which means also you can't just do experiments, because experiments can mean it's too late to address the actual problem. The second one is no central authority. There's no one place you can go in the world to say, hey, let's address this problem. We've got a fragmented system of global governance, states, countries, municipalities. 3, those seeking to end the problem are also causing it. So the war is with ourselves. If you drew a line in this room and looked at our emissions, and we were a country, we'd be the highest emissions country in the world because academics and students are high carbon emitters, okay? And yet we're also the ones that care the most about the climate crisis. We have this contradiction with our own behavior, and therefore the war is with ourselves, just the way whether we text too much or surf the web too much or smoke too much, we have these war with ourselves, but this problem is a war with our collective institutions, not just individual challenges. And then finally, policies in place discount the future irrationally. We don't mean the economics term irrational discounting, in which they base this on utility. We think that's actually irrational for the nature of the scientific knowledge we're getting. The scientists tell us that all the policies in place to date are irrational in terms of the nature of the crisis we're facing. Okay? So when these things exist, and they appear to exist in climate change, when we think of the technological solutions, to me there's a big risk that the innovations that we've been discussing today, and even out there in general, might accidentally reinforce type 3, 2, and 1 conceptions, just the way Newfoundland did this accidentally too, okay? And so bottom-up is now being used in many cases as a way to prioritize private sector engagement, non-state actors. The government isn't working effectively, and it's actually giving into the utility-enhancing nodes. And in fact, the UNEP now, United Nations Environment Program, is actually now a type 2 agency in which economics dominates their thinking and approach, which was not the case 30 years ago when they had type 4. Type 3 is all over the United Nations. The SDGs, Brundtland, it's all type 3, balancing different goals and just trying to get it right? It's Newfoundland, okay? And even in some cases, practitioners are treating type 4 problems as type 3. And this is my favorite quote from this really great political scientist, Victor, who talked about the importance of the Paris Accord in transforming global governance. And then he says in the same article, oh, but forget about the actual goals of the Accord. Okay? So he moved from type 4 to type 3 in his analysis, right? And so I'm curious about then how do we think about achieving these goals, changing feasibility, changing preferences. So then, if we need a different kind of way of thinking about these things where we constrain our future selves, we argue in this article with my former doctoral student who now works at WRI, Kelly Levin, Graham Auld, and Stephen Bernstein, that we want to think about finding triggers out there in the policy world that are easy to pull but hard to reverse. Easy to pull but hard to reverse. And how do we do that? As we can create these, what we know as critical juncture events that might withstand the type 1, 2, and 3 drift, then we could actually make a difference in this climate crisis. And to do that, we argue that there are 3 questions you want to ask. How can you design policies to create immediate stickiness? How can they be designed to entrench support over time? And how can they be designed to expand support over time? And you must theorize forward then, based on your design, the multiple pathways. Before the data comes in, you would change the data, okay, based on your theorizing. So I'm just going to give you this quickly, but we think that the way to do that then, ironically, is not one big step, but we call progressive incremental approaches that involve multiple steps over time as these things entrench more and more over time to get to a new equilibrium. And we're curious what this top right cell in our analysis. This table I'm not going to go over for you. It's too complicated and detailed, and it's also a 2x3 table, so it breaks the norms of a 2x2. But basically, it breaks down policies into much more fine-level component parts. And it says, whereas most of us think about policy tools or policy goals, the actual policy settings or calibrations, these tiny little things like, for example, a setting might be, for example, the speed limit, okay? These tiny little things over here can do some pretty cool things to trigger easy-to-pull, hard-to-reverse efforts. But they require all kinds of creative thinking because it's very complicated. You stand back and ponder the easy-to-pull kinds of levers. So, and the idea here is if you can think about a cool kind of policy basket where you pull the easy lever, but it's also durable, you can create some cool innovative efforts, which, by the way, involves a lot of learning among stakeholders. Where is the innovative idea to pull? You can't wait for the evidence. You want to change the evidence through creative brainstorming and thinking. This table has been applied to do that. Just some quick examples, though, that sometimes settings can matter more than goals and tools. I'm going to give the example of Obamacare, which is not a climate case, but it's just a cool example. I want to leave it with you in your heads, okay? This is a really awesome example. You know Obamacare, okay? So Obamacare is a big piece of legislation like that. It's a bunch of things, actually. And you know that the public option, which was a way to let Americans slowly get public insurance over time by opting into public insurance, failed in the Senate because they needed 60 votes, and they got 58. In American democracy, it's the only democracy where mathematics are reversed, so 58 out of 100 is not actually enough. 42, Trump 58, it's confusing to me as a Canadian, but this is what happened. But a small little provision in committee, said, oh, and by the way, any child 26 and under must be covered by your parents' health care insurance. A little teeny tiny change, no one really knew about it, it got passed, right? So easy to pull lever, impossible to reverse, for a different reason. If you reversed it, you would have massive mobilization in DC, parents, grandparents, children, myself, we'd all be there, right, protesting. It'd be too risky. And sure enough, Trump announces he's not going to change that, right? You can't get the data on that, you theorize it, the data only exists if you're wrong. Okay? But this is why you got to think in the future and be creative. And that's a cool example because it applies in climate change as well. It applies in technology. Cowan's research tells us that it was the U.S. military calibrations over procurement policies that actually got the U.S. into a light nuclear technology trajectory, but it wasn't preordained. It was a procurement strategy, an easy to pull lever that led to path-dependent effects. So contemporary examples, the most common one applied in the literature is in the German government's feed-in tariffs. So I just want to leave you with this one because it's actually a great technology story about path dependency, okay, applying this kind of thinking. So the tool was long-term contracts to homeowners that provided economic benefits by putting solar panels on your roof. That was the overall tool. It was actually payment. It was a market mechanism. And what was cool about the calibrations was that the electricity going back to the grid gave homeowners the retail rate, not the wholesale rate, that reinforced and locked in not just the existing homeowners who had the solar panels, but ones that didn't were like, I want those. So we got the expansion part, which also led to increasing entrenchment, because over time you got progressive incrementally improved impacts, okay? And this then had the cool effect of lowering the price of solar panels. Not because economists said let the market decide, but because policymakers got in and intervened with an easy to pull, hard to reverse lever. And that's one of the reasons why your solar panels cost less, is because of this German government's feed-in tariff. It diffused somewhere else, okay? So that's just one example. There's literally thousands of these examples all over that we're leaving sit there, not even discovering them because we're thinking about cost-benefit analysis or utility.